Welcome back, and we're on to the 26th of September, Higher Plus. So let's look at today's questions. We have some algebra by the looks of it, some combinations, functions, and a circle theorems question at the bottom. So let's go straight to question 1. Now, I'm sure I don't need to say each time, but make sure you've tried these questions first. So there'll be a small pause for each video. This one here is just a straightforward factorizing question, but there is a word that's notable, and it's the word fully. So that's a kind of clue, and clue is probably too strong a word, but it's a kind of clue that you're going to have to do 2 steps at least. So you could write, noticing this looks like difference of 2 squares, so you could write root 75 minus root 48x and root 75 plus root 48x. That won't be sufficient because you haven't factorized fully. So try and think what you could do to both the 75 and 48. Well, both those numbers divide by 3. So I could divide both by 3 and factorize the 3 to the outside. So I'm factorizing fully by doing at least 2 steps. And I say this comment every now and then. Now I'm feeling a little bit better because I've got numbers I recognize. 25 and 16 are definitely square roots. Square root of 25 is 5. Square root of 16 is 4. So therefore it's going to be 3, 5 minus 4x, 5 plus 4x. Can't factorize anymore. Question done. Next question. All right, so this is a reasonably straightforward combinations questions. There's definitely much more trickier questions than this. So what have we got? So we've got 3 choices of things. So you pick a thing in the morning, a thing in an afternoon, a thing in the evening. There's 4 choices in the morning, 7 in the evening, and an unknown amount of afternoon activities. So what I'm going to do is I'm going to note there are 3 things that I'm trying to pick. And I know from what's called the fundamental theorem of counting that if I multiply the choices together, I get 224. So in other words, 4 times 7 times x, which is 28x, is going to be equal to 224. Divide both sides by 28, and that's going to give me x is equal to 8. Not as bad as it looks, a pretty straightforward combinations question. Next question. All right, so these are the kind of questions that seem more difficult than they probably are, but it's a functions question asked in a slightly different way. So what it's saying is we have 2 functions, f of x, which squares and adds 2, and g of x, which just adds 14. And it's basically saying which value do you put in both to get the same output. So let's just do that. Let's just see what falls out. Now, there is a word that I said quickly that is quite important here, and I'll come back to that at the end. So let's write out what we've got. So we've got f of a equals g of a. So far, so good, just in the question. If I put a into f of x, I get a squared plus 2. If I put a into g of x, I get a plus 14. I've got an equation, which means I can solve it. So take away a and 14 from both sides. That gives me a quadratic. As with all quadratics, think of quickly the 3 ways of doing it. So my rule is if you can't factorize in a minute, then just use a quadratic formula. Save yourself time. But I can, because I know that 3 and 4 give me 12, and minus 4 plus 3 give me minus 1. So therefore it's going to be a minus 4, a plus 3, which means that a is going to be minus 3 or 4. Now you'll remember at the start of the question I said there's something in the question itself which is notable, and that is this word here, which is values. Now, if this was a real GCSE question, it'll probably say 2 things. So firstly, it will most likely say show all working, because it doesn't want you to just try different numbers. And secondly, if it wants you to pick a particular value, it might say value is positive or value is negative. Here, it's got the word values, so let's be clear, both minus 3 or 4 are correct answers. So the correct answer again is a equals minus 3 or 4. Next question. All right, so a bit of algebraic fractions. As ever with these questions, there's definitely a few ways of doing it, but I'm going to choose to do the common denominator approach. So what is the lowest common multiple of 4x cubed, 3x squared, and 2x? Well, I'm going to choose to go to 12x cubed. Let's make the bottom 12x cubed, and then I have to think what I do to each of those fractions to give me 12x cubed as my denominator. So for example, I'm going to take the first one, 9 over 4x cubed. I want 4x cubed to be 12x cubed, so I'm going to multiply top and bottom by 3. And let's repeat that process for all 3 fractions. So the second one, I'm multiplying top and bottom by 4x squared. And the third one, noting the negative, which again is there just to test your understanding. Noting the negative, I get a minus 1 times 6x squared. Expand all these brackets, so I'm going to get 27 plus 20x squared minus 6x squared on the numerator. Collect my x squareds together, and that is my final answer. Now, what are they looking for you to do here in error? What they're looking for you to do is cancel the x squared or cancel it. You can't do that. You can only cancel if you have factors on the top and factors on the bottom. So have I given my answer as a single fraction in simplest form? Yes, I have. So question done. Next question. Okay, so I think this question's come up before, and I think the way I did it before, in fact, I know I did it this way before, is I did the angle at center is twice the angle at circumference approach. There is another way of doing it. Both are equally valid, and you have to be very careful you're using rules that you can say are definitely true. So this is the way I'm going to choose to do it now, just so you've got a different way of doing it. So I'm going to set up 4 isosceles triangles. Now, because and I actually probably should have labeled the center actually. So to be really clear, I should put O there just to make that a center. So let's pretend there's an O there. But i.e. these are all radii, which means that these triangles are all isosceles triangles with different angles at the edge. What am I trying to show? Well, I'm trying to show if I take the top left corner and the bottom right corner, I want A plus B plus C plus D to equal 180. Now, just because of space, I'm going to do the bare minimum here, which I think would just about get you away with the answer. If we think about what we've got a quadrilateral, and you are allowed to quote as fact that the angles in a quadrilateral add to 360 degrees. So it must be the case that A plus B plus B plus C plus C plus D plus D equals 360 degrees. You would also, if this was a real question in the exam, you would write down angles in a quadrilateral total 360 degrees. Make sure you're showing what you're doing. Now, remember what I'm trying to get to? I'm trying to get to the idea that top left and bottom right, or top right and bottom left, total 180. So that's A plus B plus C plus D. And what I notice here is if I collect the terms in the right-hand side, I get 2 lots of A plus B plus C plus D equals 360. Divide both sides by 2, and I have shown that A plus B plus C plus D equals 180. Now, I don't think that should actually appear in your exam, but it's a nice little question to make sure you're okay with, because what they might do is they might do one of the questions that says something along the lines of, Johnny is trying to prove this equation. What has Johnny done wrong? So you might have to be aware of the proof, even though you don't necessarily need to do the proof itself. Hopefully you did all right on those. Well done if you did. Try again for the next set. As ever, do like the video, do subscribe because it helps everyone else see it, and do write a comment if you think there's something I've missed or got wrong, or just have a question. I will get back to you. Thanks all.